Using top-tier AI models for every single coding task is like hiring a Michelin-star chef just to butter your morning toast. The results are great, but the bill is absurd.
Yeah, it's completely unsustainable. I mean, you get perfectly buttered toast, sure. But if you do that every morning for a month, you are bankrupt.
Right, you really have to match the labor to the task.
Exactly.
Welcome to this deep dive. Today, we are looking at the April 2026 Claude Code Cost Guide.
It's a fantastic breakdown.
It is. We are unpacking how you can separate the interface of your AI coding agent from the underlying engine. And I'll be honest with you, I still wrestle with surprise API bills myself.
Oh, we all do. It happens to the best of us.
Yeah, just last week I got hit with a $40 charge for what I thought was a basic CSS refactor. I couldn't figure out why my tokens vanished so fast.
It's rough. A lot of developers are feeling the exact pain right now. You run a quick optimization script, step away for a coffee, and suddenly your token balance is entirely depleted.
Completely gone.
Right. The agentic loops are incredibly powerful, but they're also incredibly greedy if you leave them unchecked.
They absolutely are. So our mission today is very practical. We will explore two distinct methods to slash your development costs by up to 90%.
Which is huge.
Yeah. We are going to look deeply at local hosting with Ollama and cloud routing with OpenRouter. And most importantly, we will reveal a highly specific hidden configuration trap, one that quietly drains your account without throwing a single error.
That config trap is where almost everyone loses their money. It's so subtle because the software technically does exactly what it's programmed to do. It just doesn't broadcast the financial consequences.
We will get into the mechanics of that trap shortly. But before we touch a terminal, we need to establish a proper mental model. We really have to understand the underlying architecture of Claude Code.
Right, because it's not what people think.
Exactly. In the past, we talked about AI as a single monolithic brain, but that is not what is happening here.
No, not at all. Think of Claude Code more like a general contractor on a construction site. The contractor manages the project, they hold the blueprints, they walk around the site, look at your project folders, decide what needs to be built, and figure out the sequence of steps. That's the outer layer. That is the interface.
But the contractor doesn't actually pour the concrete?
Yeah.
Or install the plumbing themselves?
Exactly. They hire specialized workers to do the actual heavy lifting.
Yeah.
In this architecture, the underlying AI models like Anthropic's Opus or Sonnet are the workers.
Right.
They provide the raw intelligence to execute the specific tasks the contractor assigns them. And because the contractor and the workers are decoupled, you are not forced to use Anthropic's workers.
Wait, I want to pause here for a second. 2-sec silence. Isn't Claude Code a proprietary Anthropic product? How is it even legal to just rip out their proprietary intelligence layer and plug in a completely different model?
I know, it sounds like a violation, right?
Yeah, doesn't that violate their terms of service?
It sounds like it should, but it doesn't. Anthropic explicitly built the tool to be flexible. They own the agentic loop, the CLI tool you install, but they allow you to change the base URL and the API keys in the configuration.
Oh, wow.
Yeah, you are legally allowed to swap the engine. You just change what powers the actual reasoning.
Which means we have two main choices for that reasoning engine: closed models or open models. Let's unpack the practical implications of that choice. What's the practical difference between open and closed models in this workflow?
It fundamentally comes down to physical infrastructure. Closed models, like Opus, live externally on massive corporate server farms. You send your code out over the internet via an API, they process it and send the answer back. Open models, on the other hand, are the raw weights and architectures that you can actually download.
Closed lives on their servers. Open runs on your hardware.
That is exactly the trade-off. Closed models give you state-of-the-art reasoning without worrying about hardware, but you pay per token. Open models give you total freedom and zero ongoing costs, but your hardware takes the hit. And honestly, the open models have improved so massively in the last year that they are highly capable generalists now.
Which brings us to the first method detailed in the guide: going local. Turning your own computer into the primary server.
This is the ultimate move for privacy and cost control. If you work in defense or healthcare, or you're just deeply protective of your proprietary code base, local hosting is the dream.
Because there are zero ongoing API costs. Your data never leaves your physical machine.
Right.
The guide recommends a tool called Ollama for this. It essentially acts as a local manager. You don't have to compile complex C++ libraries. It lets you download and run models via a very simple terminal command: kind of like pulling a Docker image.
Yeah, it handles all the painful infrastructure details. You just type Ollama run, followed by the model name. It pulls the model weights down to your hard drive, allocates the memory, and spins up a local API server on your local host board.
It just runs quietly in the background.
Eh.
But there are harsh physical realities here. We need to talk about parameters and quantization. Beat. A lot of developers think they can just pull down the largest open source model available and run it on a MacBook Air.
Oh, yeah. That is a recipe for crashing your machine.
Let's quickly define parameters. They are the virtual brain connections determining a model size.
Right. A massive 70 billion parameter model is going to require multiple high-end dedicated GPUs just to load the model into memory.
If you try to run that on a standard laptop, it will immediately swap to your hard drive and grind to a complete halt.
It's brutal. For most developers working on laptops or standard desktops, a 7 to 14 billion parameter model is the absolute sweet spot. The guide points to models like Qwen 3 or DeepSeek Coder. These models are heavily quantized.
Let's define quantization quickly, too. It's basically compressing the model's math to take up less memory without losing much intelligence.
Exactly. By running them at 4-bit or 8-bit quantization, a 14 billion parameter model only takes up about 8 to 10 gigabytes of disk space.
Wow, that's really efficient.
Yeah, and more importantly, it fits comfortably inside 16 gigabytes of unified RAM. That means it runs smoothly on mid-range hardware.
But before you connect Ollama to Claude Code, the guide is very explicit about testing. You should run a simple local chat in the terminal. Ask it a basic coding question first.
Isolating your variables is critical. Claude Code is a highly complex system. If it acts strangely later, like if it loops endlessly or throws weird formatting errors, you need to know if the underlying model is broken, or if the agent integration is the problem.
You need to verify the worker is competent before you introduce them to the general contractor. Beat. But there's a very weird catch mentioned in the guide here.
Oh, right.
Even if you plan to do 100% of your processing locally, there is an initial financial hurdle.
The Anthropic cover charge.
Yeah. Hold on. If I am running this entirely locally on my own hardware, why am I paying Anthropic a dime? That seems totally contradictory.
It does feel backwards. But Claude Code itself, the CLI tool, requires authentication to start. Anthropic uses your API account essentially as an anti-spam and verification measure. It prevents massive botnets from abusing the client's software.
Okay, that makes sense.
So you have to authorize through Anthropic the very first time you boot the terminal, which requires a starting balance of about $5 in your Anthropic console.
So it is literally like a cover charge for a club. You pay to get past the bouncer.
Yeah.
But once you're inside, the open source buffet is completely free.
Right.
Your ongoing local usage with Ollama never actually touches that $5 balance.
Exactly. It just sits there. But while the buffet is free, your plate is incredibly small. We have to talk about context windows.
The context window is the model's short-term memory. It dictates how many tokens, how many words or lines of code it can hold in its brain at one exact moment.
And this is where local models struggle in agentic loops. Claude Code does not just send one prompt, it sends a continuous cascading loop of actions. It reads your code base, it writes a grep command, it reads the terminal output, it searches another file.
And it appends all of that history to the prompt every single time it talks to the model.
Every single time.
What happens if the model's context window overflows?
Well, the model drops its oldest memories to fit the new terminal output. It literally forgets the original system prompt that told it how to use Claude Code's tool.
It forgets earlier instructions and acts confused mid-task.
Exactly. And that is when the hallucinations start. It starts outputting raw markdown instead of tool commands, and the whole agent loop crashes.
It's a nightmare. So constantly pending terminal outputs causes amnesia unless we manually force the context open.
Right. The fix requires manual intervention. You can't just run the default command. You have to edit the Ollama model file or pass specific environment variables to explicitly force a larger context size. Pushing it to 32,000 or 64,000 tokens changes the behavior dramatically. It stops forgetting its instructions.
But forcing a massive context window on a local machine is physically demanding. If you open a 64,000 token window, your unified RAM is going to max out. If your laptop sounds like a jet engine trying to run it and your battery drains in 20 minutes, local hosting stops making sense.
Right.
We need a different approach. We need to move the compute off our hardware.
And that requires the cloud.
Insert provided mid-roll sponsor read here.
So we have established that your local hardware is maxed out. Your fans are screaming, and you want your battery life back.
Yeah, the guide suggests moving to OpenRouter.
OpenRouter is a brilliant piece of infrastructure. It keeps your entire workflow online and off your local GPU. But instead of routing Claude Code's requests to Anthropic's expensive servers, you route them toward free or heavily discounted cloud models hosted by other providers.
It is essentially an API aggregator. It gives you a single, unified endpoint. Through one API key, you get access to hundreds of different models from OpenAI, Meta, Mistral, and dozens of independent open-source hosts.
You get this massive library of compute. And because you are just changing the base URL in the configuration file, the Claude Code interface does not change at all. You still get all the powerful tool calling.
But the guide highlights a very specific financial hack here. If you just sign up for OpenRouter, their free model access is strictly limited. By default, you get roughly 50 requests per day on the free tier.
Which is practically nothing. 50 requests might sound like a lot for a web chat, but in an agentic loop, Claude Code might make 20 requests just to investigate a single bug. 50 requests per day is fine for a quick test, but it's entirely useless for actual sustained development work.
So here is the hack. You go into your OpenRouter billing dashboard and you deposit exactly $10. You fund the account with a credit card. The moment you do that, your rate limit for free models jumps from 50 requests to about 1,000 requests per day.
Wait, if OpenRouter advertises these models as free, why do I have to give them $10? That sounds like a classic bait and switch.
I know, it feels like a trap. But it is actually a security mechanism. OpenRouter hosts these free models as a loss leader to attract developers. But the internet is full of malicious actors who write scripts to spam free APIs.
Oh, sure.
By forcing you to use a valid credit card to deposit $10, they prove you are a real human, not a botnet.
And here is the crucial mechanic that makes it a hack. That $10 never actually gets consumed by your free tier usage. You are using models explicitly tagged as free. The meter is running, but the cost per token is literally zero. Your balance stays at $10 forever.
It functions exactly like a library card. You put down a small deposit to prove you're a responsible citizen, but the books you check out remain completely free.
Whoa, imagine cutting your dev cycle costs 100x just by rerouting the engine. Or running massive automated code-based refactors overnight without ever worrying about the meter running. Your development cycle is no longer constrained by your API budget.
It completely changes how aggressively you can deploy AI in your daily workflow.
It really does. You generate your single API key in the OpenRouter dashboard and you are nearly ready to go. But the guide emphasizes a critical detail about model selection: beat. When you configure the router, you have to type in a specific model identifier string.
Why should we pick a specific free model string instead of just using the generic OpenRouter free setting?
You might be tempted to just use the generic string, something like OpenRouter Auto. It seems easier because you don't have to look up the exact technical name. But if you use the generic string, OpenRouter acts like a load balancer. It just picks whatever free model happens to have the most available compute capacity at that exact millisecond. One session, you might get a genius-level model. 10 minutes later, the router quietly hands it to a weaker model that completely hallucinates your file paths.
Generic routers cause inconsistent results. Specific models make debugging easier.
Exactly. It's totally unpredictable otherwise. You want absolute consistency. You need to go to the directory, find a specific identifier like a Mistral Nemo variant, and put that exact string into your configuration file.
Right. You have your massive free rate limit unlocked. Your specific model string is chosen. But now we arrive at the most dangerous part of the guide, the massive hidden configuration trap waiting to quietly drain your Anthropic account.
This is where everyone loses money. This is exactly what caused your $40 CSS refactoring bill last week. We have to talk about the settings.local.json file.
Yeah, to make Claude Code talk to OpenRouter or Ollama, you have to edit this specific hidden JSON file in your project directory. You replace your Anthropic API key with your OpenRouter key, and you change the base URL. That part is straightforward.
Right. The trap lies in the model definition fields.
When I set it up, I changed the primary model field to my free OpenRouter string. I assumed that was it. The agent was using the free model for the main chat.
But Claude Code is not a single process. It relies on subagents. It uses a heavy model for complex planning phases, but it is hard-coded to use smaller, faster models for background tasks. It uses subagents for reading massive log files, summarizing folder structures, or making simple tool calls.
Are you telling me that overriding the main model wasn't enough? Because it didn't throw any errors. It just kept working.
That is the trap. If you only change the main model field, the software looks at its internal logic. It needs to run a fast tool call. It checks your JSON file for a fast model or tool model field. If those fields are missing, it does not fail.
It just silently fails over.
Yes, it quietly falls back to its default programming. It reaches out over the internet and uses Anthropic's paid models like Haiku to execute those background tasks.
And it does not warn you in the terminal. The main chat looks completely normal. You think you are running your entire workflow for free on OpenRouter, but your agent is secretly racking up thousands of background tool calls against your Anthropic API balance.
It takes developers an embarrassingly long time to realize this. You must manually override every single model field in that JSON file. You have to explicitly define the model, the fast model, and the tool model with your free strings. You have to force the software to stop calling home.
How do we actually verify that we successfully bypassed this configuration trap?
That is the only way to be absolutely certain. You cannot trust the terminal output. You have to launch Claude Code, run a real multi-step task that involves reading and writing files. Then close the terminal, log into your Claude usage dashboard, and look at the actual API receipts. You are looking for a line item that explicitly shows API calls with a build cost of $0.
Check your logs for $0 API calls. They're your receipt.
Yes. If you see the $0, you are safe. The trap is avoided.
Our setup is now bulletproof. It is truly free, and it is stable.
Yeah.
But we have to talk about strategy. We have to divide the labor.
You cannot just run all your code through the free models forever. They have inherent limits. They are highly capable, but they are not magical.
They struggle deeply with complex tool use. If you give a 14 billion parameter model a task that requires chaining together 6 different terminal commands and analyzing a massive stack trace, it will likely fail.
Yeah, many of these open source models were not natively trained to follow Claude Code's highly specific tool calling schemas. They get confused by the XML tags. They take shortcuts. They try to guess the answer instead of running the search command.
So the ultimate goal isn't just magic, free infinity for every task.
Precisely. You have to implement a strategic division of labor. You use the free models, your reliable line cooks, for the boring, predictable 80% of your daily tasks.
No, it's about right-sizing cost by matching tasks to capabilities.
Exactly. We're talking about summarizing large markdown files, searching or grepping through a massive legacy code base to find variable references, classifying basic GitHub issues.
Writing repetitive boilerplate scaffolding.
Things like standard CRUD endpoints. Create, read, update, delete. It is highly predictable structure. It is basically like stacking Lego blocks of code. You do not need the smartest intelligence on the planet to write a basic database query. The free models are perfect for this low-stakes routine work.
But you fiercely protect your premium budget for the high-stakes work. When the problem gets difficult, you swap the engine back. You bring in the Michelin-star chef. You switch your JSON file back to Claude Opus or Sonnet.
Right. You use the premium models for designing complex system architecture from scratch. You use them for debugging subtle, non-obvious race conditions or logic errors that the smaller models cannot even see.
You use them for writing critical path production code, decisions that are hard, expensive, or dangerous to reverse.
Any task where a hallucination has real, painful financial or structural consequences. That is where you actually spend your tokens. Lower-cost models do the tedious groundwork. Higher capability models make the final, complex decisions.
Let's summarize the big idea from this guide. The goal was never to replace Anthropic's intelligence entirely. The goal is to build a balanced, hybrid development ecosystem.
You keep the amazing interface. You keep the powerful agentic planning loops that Claude Code provides. You just strategically swap the engine based on the immediate context of your work.
Local Ollama models give you total privacy and zero latency for sensitive, proprietary work. Free OpenRouter Cloud models give you the speed and scale necessary for massive, routine scaffolding without melting your laptop.
And premium models handle the heavy architectural lifting that actually justifies their high cost. By meticulously right-sizing your costs and avoiding the fallback traps, you transform a tool that could bankrupt you into a highly efficient, sustainable daily workflow. It gives you total control over your development cycle.
It is simply a smarter, more deliberate way to engineer software. I encourage you to go open your own project folder today. Look at your settings.local.json file. Even if you just pull a small local model to test your hardware limits, see how it feels to run the engine entirely in your own garage.
Just remember to check those usage logs for the $0 receipts before you walk away from your terminal.
Always check the logs. 2 sec silence. I want to leave you with a final thought to mull over. We talked about how fast these quantized models are improving. As these open source 14 billion parameter models rapidly close the capability gap month by month, what happens to the entire AI coding landscape when the free local engine becomes completely indistinguishable from the Michelin-star chef?
That shifts the balance of power entirely.
It really does. Until next time, keep diving deep.